So sometimes we say this is VA, this is VB. So now VA will change to VB. However, here we could create a noise. So we know this is the crossover point. But sometimes the voltage is not so good. So the voltage could create noise. So you have here and here. But if you have noise here, then I made a mistake because I found this one and this is larger than this one. Then I switch this point, right? So this is ideal case. We have touch here. But the voltage has some noise. So sometimes it can make a mistake. You could switch here or you could switch here. So we call this is critical areas. And sometimes you make a mistake. So problems may occur when the voltage are very close. So if here I know VA is the big one, if here I know VB is the big one, if here I know VC is the big one, but here I could have made a mistake. I could have said, oh, VB is larger than VA because of noise. So this point is very hard to decide. So we call this is critical area. So could commutate by the other voltage. If you made a mistake, then you create more loss. So we could rearrange commutation sequence. But this is not a big issue because if you made a mistake, you only create a larger loss, but a never damage. So it is okay. So we compare the communication method. One is output current communication method. So rely on measurement of the output current. How can you measure the output current? You can put a current sensor at the output, but it costs a lot. So we can use the IC to detect the current. We can detect the voltage of the diode and the IGBT. Then we know the current direction, right? The output line open circuit if a commutation error. If you have an error, then you create communication error. Then what happens? You create over voltage. You create a spike. And we also have input voltage computation method. We rely on the measurement of the input voltage. So it takes longer computation time because it is quite slow. So sometimes we made a mistake. And the input line short circuit is a commutation error. When commutation error occurs, it could be short circuit. So this is dangerous. It create short circuit. So we have another protection issue. Overcurrent due to short circuit. If two switch short circuit, then what happens? You burn out. Can you protect yourself to make the power device still safe? So we call overcurrent short circuit protection. Loss of power supply. You need gating, but your power supply failed. Then you do not get. Then what happens? Protection strategy. So we cannot use free theory. So it is very hard. We have to provide energy storage, but now we have no energy storage. Before we have huge capacitor, but now we do not have energy storage. So the energy could be unbalanced. Sometimes if you add a load, then the energy cannot balance. So you create some problem. So sometimes you need over voltage clamp to avoid spike. So sometimes you need a free fairly circuit. So how can you design this kind of protection circuit. So you say, oh, I have a good way. I put a diode. This is from output. This is from input. So if input have current, then they can go here to charge the capacitor. If output have spike, then they can go here to charge the capacitor. So this capacitor can absorb energy, like our DC convert capacitor, right? If you have spike, then they go here. So capacitor is typically very small. I mean, this cannot be too huge. Depends on nature of load. For the matrix converter base, aircraft actuator used in the airplane, the machine inductance 1.1 millihenry. The maximum output current 30 ampere. How about this capacitor? 2 microfarad. Small, very small. How about a DC link capacitor? 1000 microfarad. So compared to this, it is very small. So what should you do? You have to design this circuit. If you have spike, because you cannot protect, so you can use diode to make the spike come into the small capacitor. Then the capacitor can absorb the energy. Then you will be safe. So you have to design the, we call snapper, but we do not call snapper. We call it is clamp circuit. So our spike go to the clamp circuit. The clamp circuit like a leg. Then you can absorb the energy. Then you will be safe. So it is only 2 microfarad. So I think I will stop here and we'll see you next week.